Started. It's been a few months. Oh, we gotta get those captions on. There we go. It's been a few months. I'm trying to get back to doing a little more streaming. We got GWT 2.11 out the door, and working on what we're going to need to get GWT 2.12 going, which mostly is about Java 17 support. So over here, let's just make sure captions are going. Yep. Pretty quiet here so far, owing to the fact we haven't been streaming in forever. So we've got an epic in the issue tracker to keep track of all the things we're going to need to do to build Java 17 support. And it's this chain of dependencies we need to get right. We need to first drop Java 8 support, running on Java 8 that is, because the JDT version, which is the Eclipse compiler that GWT uses to translate Java to JavaScript, in order for it to support Java 17, the first version that supports Java 17 in a stable way is going to require that we no longer run on Java 8. It's built on Java 11 bytecode. And then from there we can say, okay, now that we've dropped that support, we can talk about some backporting, which we don't have an actual ticket for yet. We can update the JDT itself. There's a pull request pending for that. I have the error-prone work merged into this issue. I've got both of those up right now and trying to go through and cut out some of the other changes we got to make in the process. And then we've got the various features we need to implement. The first two are going to be test-only, text blocks, and sealed classes. The pull request right now that Ahmed has started for the JDT upgrade already includes tests for these, so we'll get all three of those closed in one step. And then we need to work out record types, pattern matching instance of, and then switch expressions. So record types, about a year ago, we put together a sample that shows how to build all that stuff. It didn't have a good set of tests, and I can't remember what else we had that we didn't like about it yet. So we'll have to crack that back open and see what's going on there. The pattern matching instance of, Ahmed has been starting that, and that turns out to be a little trickier than it looks like. There's some structural changes, minor structural changes that have to happen near where the instance of itself is added, because you effectively have a new class declaration. And if he's around, we will see if he can talk to us about what that's going to look like, what the code looks like. And then I have started some discussion in this issue for switch expressions to say what kind of a thing we're going to have. So if you have an expression that does a switch, this is a weird example, but that's sort of the point of saying how do we find the weird examples and build them out. If you switch on 0 and then you just have a default, you now can execute lines of code inside of an expression. Notice that this expression here is being passed as an argument to some method. So basically, you can use this as a very simple construct to put a couple of lines of code here where you previously could only do one. Now this is a weird example too, because I'm just making a list and adding a couple items to it. You could just do that with streams or something instead. It's weirder still that we are doing something which will mutate state. And the point of mutating state here is to say, according to Java's rules, first we evaluate this, then we evaluate whatever was passed in here, we evaluate this. If it matches true, then we'll start evaluating this. So this operation here must come after this one here, which means we can't do something like move this whole segment up above here as another block of code, and then assign the yielded value to a temporary variable and put it here. And so down here, then we've got two different examples of how we could implement this behavior. The first one is very nearly what I just said, where we move the switch up to a switch statement. It becomes a switch statement. It has child expressions, and then we assign to arg2. But in order to pull that off, we have to first assign to arg1. We have to pull this out because it must execute first so that this order of operations is held. And then it looked a little simpler to say, well, what if we could just pull this out into its own method and have this close over any of the arguments it might need, something like that. Because this would guarantee that the order stays the same and the structure even stays the same. This just becomes the switch expression just becomes a method expression. The problem with this is I believe you can do things like assign to other locals in here, and that would no longer work if it was a separate method. You can't somehow return multiple values here because we're still working in Java, and they haven't changed that yet. So this looks like the way forward. Leave that method intact, extract each of the other arguments as you encounter them to assignment statements with temporary variables, and then extract a single argument for the result of the union of all these yields, and then produce this here replacing our yield with assignment and break. This has to be a final. Your switch expression, I don't know if you've looked at the spec, it's kind of fun to read. It's very approachable. These have to be exhaustive, which means you must have a default if there's any other blank space here. So here's the JEP itself talking about, here's what you have to do today, here's what the proposal is that you'll be able to achieve now, how long things will get scoped, newly assigned things. So you still have the same problems as we previously had where you can't reassign these things. We're not going to worry about that so much. You can declare it outside, and now you can assign it inside. So this is the problem we were worried about. How do you assign to other locals, or do we support that? This is, let's see here. I'm not sure exactly what we're showing here. This is just saying, hey, we could simplify this out now to say, instead of assigning, oh, maybe not. Maybe I misunderstood. I believe this is still valid to assign even when you're in here, but we'll have to validate that to be sure that's a real concern. Anyway, it's very readable. The URL is pretty simple to find. It's JEP 361. It is referenced from our issue 9878. So to get this started, like I said, we've got this chain of dependencies we've got to go through, and the first step here is updating error-prone to drop Java 8 support and prepare us to run on Java 21. And along the way, we found a bug in the JDK. We discovered that one of the tests in GWT to verify a bug that Gwt had encountered before GWT was even open sourced ends up tickling a bug in Java 9 Plus. And they have fixed it since I last looked at it. So 2 days ago, they went through and fixed it. You could write this crazy convoluted thing here where you have a local variable, you assign the local in a ternary, and then later in the ternary, you use the variable. And it turns out this generates invalid bytecode. And it looks like they may have backported the fix. It was submitted for review. Sorry, you can't see that part. And I'm curious how far it's going to get backported. Effects version is all those. Fix is in 23, so they might not be backporting this. Interestingly, you don't have to actually call... Oh, this is different. This is different than what I had. You don't have to actually call this code to produce the bug, because it produces bad code. Okay, and here's another workaround. X string concat inline when compiling. We might use that instead of no verify, because that's a little better. So that's cool. They've got it fixed. Pushed as a commit. I don't see where the commit is commenting to say here's the link to this issue, so they must not do the fixes thing to point this out. Here is the example on how to run it and how to test it. Okay, well, I'm not too worried about the specifics here. We just need to keep an eye on our tests working cleanly without saying, hey, you have to run Java 23. It would be worth us experimenting later on to see if we can use this flag instead of no verify to produce valid bytecode. It has a bot type that is a complex expression with the side effects of short-circuiting it leads to complex semantics. Okay, so the problem is that the string concatenation logic thinks that this is simpler than it is. But instead it prints null. Interesting. So this no longer generates invalid bytecode because it runs. My example actually generated bad bytecode. And then we got a validation error. Interesting. All right, well, in any case, we're not really too worried about that. I am going over this to see what other changes we need to make here to get this patch ready for review. Just going back a couple of steps to where we were. This is going to update our error-prone version to run on Java 21 and drop Java 8 support. So we need to have 2 fix markers in here. Let's go back to the epic and make sure we are fully satisfying this. So let's see. Number 1, where possible, we leave Java 8 support in GWT servlet and request factory server, but any code that uses the JDT can now only use Java 11. This enables updating JDT. Past that, we have to drop Java 11, move to 17, which we're not doing at this time. And then update error prone is this ticket. Okay, so we are going to update to link to both of these. 9870 and 9859. All right. And that should link those issues to us. And then I'm going over the changes to make sure we've got everything right. There's a few things we're going to want to revert before we really get started. So first of all, we drop 17. And I started to add notes about how we're adding a 21. We can't actually add 21 at this time. Adding 21 requires that we... sorry, brain got stopped there for a moment. Adding Java 21 requires that we also update ASM. And then there's a separate pull request for a bug that is fixing a change in the list, Java util list, that needs to land first. So I'm going to put this patch together to say, hey, we need to support the new methods get last and get first, which return generic args, which ended up making the compiler think that you could traverse other nested beans. And that's not true. And then I had a comment here to say, hey, let's clean that up before we merge, and then we'll go ahead and land that. So we need that also before we add 21. So for my cleanup work, I need to drop the 21 node here. I need to change these 21s back to 17. We need to roll back our own, use our custom build here of error prone. And then let's go through the rest of this. We've dropped is Java 8 in a couple of places. We no longer check at all for Java 8. Update the version of error prone. We no longer have this Java C jar as part of the build. What else do we have? We drop source and target because those don't exist as of Java 9. Or rather, you should use release instead, which we already have. And then we rewrote each of those to get rid of the unless true, Java 8, because we always add them now. Yep, same thing there. I also went and rewrote all of these error-prone checks that we were disabling. And as you can see here, there's a whole bunch of Java files that were edited. And those Java files now on an individual class-by-class or method-by-method basis, we have markers to say, hey, disable this particular feature. We don't need it anymore. Or we don't need it in this class. And there's usually some good reason for that. And why did that disappear when I hit that? I'm switching to check another chat that I want to make sure is not yelling at me. Oh, I see. It's just slightly over the edge there. That's the problem. So we'll look at that and see why that has changed in a bit. Drop those args there. Drop these args here. Drop these args here. Now on a method-by-method basis, we're saying hey, go ahead and skip this. This particular one is in the linker itself, which we previously used just as a quick, hey, is that flag present or not? Because a custom linker does not have to have that field, and that's the particular protocol that they decided to go with. Default methods didn't exist yet, so we had to make fields instead, I guess. A lot of this code predates even Java 5. Most of the rest are in tests, because often when we are testing something, we're going to be doing something a little wonky, especially when we're building a compiler. We want to say, okay, are these things actually the same? Is this thing the same as itself? Is the expression A equals A actually compiling out to the right thing? However, these are JVM tests, so it's a little weird to have these exclusions in here. I am not here to rewrite tests, though. Someone else can pick this up and repair it more if they want. Once we get into the compiler stuff, let's see, this is testing generic classes. This just doesn't make any sense. This is just nonsense here. This should say comparable of generic class of T, but instead it says comparable of T. So that's weird. I don't know if there's a good reason for that in the test. But that's not really the concern here. The concern here is just getting things to build again in a separate pull request. If someone wants to go through and get rid of some of these suppressions, they're more than welcome. So anyway, suppression, suppression, suppression. We no longer are limited where we can run the emulation doc building. Previously, in order to update to the new API for JavaDocs, we had to drop Java 8 building those docs, and now we can run them everywhere. We need to add this no verify because of this particular bug. That way we can build on Java 11, 17, and 21. The fix, as we noted, is only for Java 23. We can drop some of these custom, hey, if you're doing Java 8, we have to exclude some other tests. We're going to be using SuperSource to avoid that problem in the future. Just went ahead and disabled these across the board now. So this all looks right to me. I've got one more local commit that was thinking of a couple other things to clean up, but I don't think we need it anymore. We still need to, let's see here, do we need to split this anymore? This was compile test for user, compile test for Java 8, and then separately compile test for Java 11. And now we just have one great big compile test that does everything. So that's where we want to be. It's building for release 11. So here is where this Java C would need the call that was suggested. Let's see here. This is about the verify error itself. I think the pull request is where they said this. Yeah, we could try this here. Try putting that in instead. That would make things a little easier for building. Where's my pull request? I have lost it. Here we go. I think it's X no verify, right? No, just no verify. And then I'm going to link the pull request that noted this. All right, so we'll follow up on that, just writing it down, otherwise I will forget. We already said we're deleting this. We don't have any need for this anymore. We have some more suppressions. There's a whole bunch of suppressions throughout the client code tests. And now this is where we are truly checking the compiler to see what it does. Here's an annotation test that didn't implement an annotation correctly, but that's sort of not our problem here. Compiler tests, coverage test. Just going to kind of skip through these as long as they are just suppress warnings. Okay, that's it. That's all we have to do here. So it looks like it's just the two things to correct. Drop 21 in the full check and quick check, and then rewrite these no verify flags. And then, of course, test and verify that it works properly. Let's see here. Computer was making noises like there was somebody I needed to listen to. But I don't see anything urgent and pressing. So let's carry on here and clean this up. I want to see my local Git history. Because it looks like I have another commit that I need to worry about here. So this is my local code, but this is the code that I pushed for this branch. 9870 drop Java 8. Oh, no, this is error prone test. Oh, hang on. I am off a little bit here. I wonder if I rebased or something. What's the difference here? Update error prone test. I think I just read it wrong. But it looks like I pushed this. This says 11 commits, but I only see about 1, 2, 3, 4 commits. Something's not right here. What am I doing wrong? Why do I see different history here? That's the last commit here. This one corresponds to this. This corresponds to this. Target name, remove, rollback, no verify, disable. Okay, so that looks right. And this says origin drop Java 8. Oh, I see. I was looking at the wrong branch. Update error prone test is not the same branch name as drop Java 8 test. So I think update error prone test was another attempt I had to do the same work. So let's look at this and origin same. Make sure they are at the same commit. They are. Okay, that's where we're going to proceed then. So what's the difference between this and, let's do this one. Okay, so this is much smaller code. I tried to cherry pick it off so I could do some other changes, and it looks like this ended up being a better approach. Okay, so we're going to pretend that this doesn't exist. Awesome. Oops. Okay, so the first thing we're going to do is look at GitHub. This is the wrong project. I just accidentally swapped out for Jackal. Where did it go? It's over here. There we go. Okay, we are going to look at GitHub workflows full check. We are going to get rid of this and just say Java 11 and 17. I think we'll rebalance these comments. No, that's too long, I think. We'll just leave it there. 11, 17. We're going to leave this here for now for another round of testing, and then we'll get rid of it. We're going to hopefully come back and get rid of this. Let's go ahead and presume that that will work right now. I'm going to roll that back to 17, and that should be that. And then likewise, we're going to make the same change here. So we reordered these. We dropped 8. This is still accurate. We're getting rid of that. We got rid of 21 for 17, 21 for 17, so we're just reverting those. Still accurate. These are just 17 to 21, so we're reverting that. And okay, so that should be pretty clean now. Let's go look at the no verify here. See if we can remove that, and then instead add our specific check for, here's the magic flag we need to add for tests. And this goes about line 275. All right, and now we want to see, is there a way we can pass more JVM args here, compiler args? Can we just do that? Okay. And now let's see if we can even run our tests here. So let's see, which test was it that caused this problem? It had this funny little b equals true null null thing. So if I just search for that, all right. This was my test example to reproduce the bug. Here is the test itself. This is in compiler test. Compiler test, I believe, is in the extra compiler suite. Extra compiler suite, yes, that's where it is. Okay, so we're gonna call, let's see here, cd user. Here's the extra compiler suite. And then we will roll back this change one more time to make sure that that is indeed fixing it, because we want to see it fail to make sure this fix is the fix. While we're waiting, let's look for more no verify. Make sure I got them all. Nope, we need to remove the comment, because the comment doesn't apply anymore. All right. All right, there will shortly be some compiler suite entries in here. Right now we got the JRE factory test suite because I was working with Ahmed on why on earth we were getting null pointers inside AutoBeans. Okay, so it compiled, and it has already gotten this far into running it. Now remember, GWT tests have to compile the Java to JavaScript first before we can actually execute the JavaScript. Just loading the compiler test at all, to say that it's part of the suite, ends up failing the test. So as we'll see in the next run, this should fail basically instantly if it is going to fail. But our change here of adding this extra JVM arg to the compiler to disable the string concat feature should resolve this. We are going to want to test this on Java 11, 17, 21, even 22 or 23 would be nice. I don't know how to easily get a 23 build. 22 is the latest available, right? Pretty quiet out there in chat. Let's do Adoptium. See what they got going on. All right, seems like we got past that. Let's see if we've got a test file here. That's the non-GWT stuff. Here's the GWT draft report. Looks like success. Unsafe reference to string object to string. Instance methods from object should not be called on that. Within a JSNI method body. Okay, that's just a warning for don't write bad JSNI, you jerk. Which is expected. Okay, let's see here. don't know what that's about. 21. Where do we have our downloads? Latest is 21. That's LTS. We want to see if we could maybe grab a 22 build here. They don't seem to have 22 builds. Okay, that's fine. Maybe I misunderstood. And 22 is not available yet? Anyway, if somebody knows, let me know. Crickets, yes. Saying the word crickets. Thank you, Justin. Okay, so that did pass, and now we're going to make sure it's going to fail by commenting it out. That should require to recompile this, this. And the bytecode that it ends up generating, I made a quick sample here for what this looks like. Bytecode should look something like this, but the bug causes it to do this instead. Let's see, first of all, which Java do we have running? 11, so this will have the bug. Java C foo .java. I'm in the wrong directory. There we go. And now the Fernflower decompiler that that IntelliJ comes with takes a look at that code and says, this is garbage. I don't know what's actually happening here. The code should look like this, which is obviously, garbage. But instead it generates bad bytecode. And if we do a Java p-v on foo.java, foo.class, we can say, okay, so what's actually happening in your unused method? I'd actually find the unused. I'm not great at reading this stuff. I'm trying to get better because it comes in handy in the weirdest places. I'm going to have eventually a blog post about taking apart code using the decompiler like this. I don't think I want V, I think I want C. Here we go. Here's method unused. This is where it calls method unused, but I don't see where the code is for method unused. So that's a little weird. Anyway, it's bad bytecode, and the result of trying to run with bad bytecode is usually that it very promptly fails. I wonder if it didn't recompile because of that. So we're going to want to run this test again twice to be sure. We're going to get rid of user test, bin test, here we go. So we'll run this test at least 2 more times to make sure we've got it, and have the very simplest, most restricted fix, because we don't want to turn off no verify for everything if we can help it. While we're waiting, we can try that same flag from the command line and see if that fixes it. All right, and then if we try to look at the bytecode here, it makes sense again. All right, so to show what the bug is that we're getting, if we Java C foo itself, it runs great. And then if you try to Java foo, you get this verify error, bad local variable type. The top type is not assigned to integer. It should be a string or something instead. And the bytecode is just apparently nonsense. Unused has an I load, which I think is load an integer from a particular slot, which I think is 0. And that ends up no. If you do, this is the really fun part. Because we don't actually call unused, because if we don't actually call unused, we can Java C it, we can try and run it, it will fail. But if you say, never mind that nonsense code, and say no verify, it will run correctly. Everything seems to work. But as soon as you start calling this method is nonsense and things won't work anymore. So we'll put back in the unused. We will compile it again, run with no verify, and it says null false. So this is supposed to return ternary, which is null on either side, so it's going to return null, and then it's going to return B. B starts its life off as false, well, unassigned, and then it's assigned here unconditionally to true before we evaluate it. So it should be null true. And now if we use this different compiler arg and run the code, with or without no verify, we get null true, which is the correct behavior. Anyway, that's what the GWT test was trying to solve to begin with. Okay, so now this failed in 0 seconds. And the error message we will see is invocation target because of verify error. Right. So now that we have successfully failed, we want to put the compiler arg back in again. We're going to make sure we're going from a clean start here. It's going to take 1 minute and 19 seconds to rebuild all this code, but whatever. There we are. So if that all works, let's go ahead and start the commit. We're going to push with the suffix on our branch -test, which is going to run all of the integration tests in GitHub in each of the supported JDKs that we have right now. So it's going to go ahead and kick off here. This was a nightly build. So for example, we'll see after we push this, instead of building 8, 11, 17, it'll just build 11 and 17. And then we'll be confident this patch is ready to go. After that next round of successful tests, I will merge the companion patch for this that will, notes for it are here. Do I not have the notes for it here? Oh, here it is. This PR requires tools 29 to merge first, and this adds the newer version of error-prone. All right, tests seem to have passed. We got this 47 seconds here on our draft tests, and then our web tests will be next. And then we'll push it. Actually, I'm going to go ahead and push it now, because I'm pretty sure it's going to succeed. We are 1 commit ahead from upstream. Let's go look at the... Oh, I should not have closed that, huh? That was dumb. So a quick smoke test is going to run to make sure the basics are sane. And then here's the full build for 11 and 17. And let's update this by adding a comment to it. here. We've already got notes. Okay. That will run once we've got success on this. We will merge the tools change, and then we'll merge this change itself, and then we'll be off to the next piece of getting 17. So let's pretend that we've got all that done already, and take a look at some of the work Amit's doing. I'm sure I've got everything already. I might not have his repo right now, actually. Let's look at his pull request. That adds latest GDT and ASM. His branch was called Java 17 support. All right, so here's what we've got here so far. Some JS compile tests. Let's go through this with a stat so we can see which files were changed in each commit, and then take a look at what changed. So we now have this Java 17 test. We also have Java 17 AST test. So let's start with the Java 17 AST test. And remember, we looked at the you can't see my fingers. I changed my camera setup a little bit. That way it was, more of me and less of this, lovely wood paneling in this very old room of my house. We looked at the epic that described all the various Java 17 features we're going to need. And text block should not need any custom work out of the box just to start working. We should just be able to say, hey, here's some Java code. Why are you highlighting funny? That's weird. Huh. I think IntelliJ is not happy about something. Anyway, we should already be able to make new text blocks and have them compile. We should already be able to make sealed classes. So this, as far as GWT is concerned, isn't a new feature. The JDT picks it up and says, it doesn't matter that it's multiple lines. That's just syntactic sugar for adding new lines. So now instead we just have a plain string that comes into GWT. There's no special syntax we need to do to write it out as JavaScript, and even if there was, we'd want to optimize it as just a plain string anyway. Sealed classes are the same. There's nothing that needs to be done for sealed and permits to generate valid JavaScript. We just need to say, hey, this has only 2 subclasses. And so the type checker, when it actually looks at your Java source code and your bytecode and everything like that, needs to ensure that these types just make sense. So there's nothing we have to do here to say this class exists. It may only have 2 subclasses. That's basically what sealed classes are about. Remember we were talking about switch expressions half an hour ago? The whole principle of those being exhaustive, the important thing about sealed classes is that you can say, I know for sure that there's only 2 possible subclasses of this. So if you have 2 instance of checks, or 3, if you have, it's going to be a shape, square, or circle. As long as you've got those 3 cases, you don't need a default because there can't be any more cases. As soon as sealed goes away, though, that wouldn't be true. And then we make a specific square class and a specific circle class. And then he made an enum, which we're going to use for our expressions stuff. So test blocks is going to succeed. This is a test that says grab our text block instance up there, which is an interface, and just make it into an anonymous inner class. From our program, find our text block type, grab its initializer, and make sure that the initializer had a multi-line string in it. So it's basically, did the compiled GWT AST include this? So for those who don't really play with compilers and have not dug into the GWT compiler itself, there's the idea of an AST is it's an abstract source tree. It is, what if your program was not text, but code, data structures. It's a giant tree. This method, its parent is the class. The method's children are things like its return type and its arguments and its throws and its body. And the body might have a single statement here, like this assert equals. What is going on with my selection? And this statement here, it is a method, but it has arguments. And this argument is just a string, and this argument has children. The argument's children are a method call, and the expression that gets passed as its argument. So you can recursively build up these tree structures. GWT starts off with running JDT, which is the Eclipse compiler, and it says parse all this code and figure out all the types and make sure it all makes sense. So that's our first AST, which we're going to put over here because that's the left for you. Then we take that and we say, okay, to do our optimizations for knowing that we're compiling to JavaScript, we want a slightly different sort of Java-looking AST, and that's GWT's own AST with things like JProgram and this initializer, JString literal, JInterface type. Any type you see that starts with a J in the compiler is going to be GWT's own AST types. And 90% of the time, that's what you're dealing with, unless you're building new compiler features. Almost all the useful and interesting optimizations run on these J types. And all of these have one common super type all the way up at the top, which is JNode. And JNode is the base class for all of our visitable AST nodes. All of our compiler optimizations that say, hey, it looks like you don't actually use that thing here. I'm getting added to a meeting. This could be exciting. Let me see how exciting. This is somebody who doesn't know what they're doing. Great. This is a fire drill about a dangerous, scary, awful dependency which doesn't do anything. I'm going to see if someone else can handle this fire drill. And if not, I may have to go play with this. Oops, there we go. Okay, someone has to feel good about a new vulnerability that they believe they discovered, and so they are yelling at us about it. I forgot what I was doing. Anybody remember what I was doing? AST, right. So we've got the JDT AST, we've got the GWT Java AST, and then way over here we've got the JavaScript AST. And when we take all this Java stuff and we've optimized it and we've normalized it, normalization here means we have taken away the things that don't make sense in JavaScript. We've normalized away those nodes by rewriting them something else. Then we can start to generate JavaScript out of it. And the JavaScript is what ends up in your compiled output. When you run the compiler, the first couple of seconds, maybe, is JDT running. Then we have to rewrite all that code once into the Java AST. We must do the normalizations for dev mode. We might not do the optimizations if you want it to go fast. But for your production code, we run the optimizations and we run them in a loop until there's no more optimizations to be made. Then we take that, we rewrite it to JavaScript. There are a few JavaScript optimizations that also happen that can't happen earlier because of stuff like JISNI, because of just intrinsic differences between JavaScript and Java. I don't fully understand those. I have spent very little time in that area over there. Anyway, those also optimize until they reach a fixed point. Say, keep running and running and running until there are no more changes that are possible to be made. So first, we are testing just, sorry, not this one. Yeah, this one here. First, we are testing, can the JDT read your code? And can the GWT AST be written from that? And the particular class that does this is the GWT AST builder. And I don't think we have any commits to this for this branch. Ahmed's around, he can correct me. Let's see, I want the history for this file. It looks like there are some changes to this file. I don't know why I can't click on things. It's really frustrating. It's probably still figuring out this file. So this is a huge file. My line numbers are not scrolling either. There we go. This is the single file that goes through and rewrites the JDT code into GWT code. And once that's done, it's done, and we live in GWT land after that. These red statements are because I don't quite have IntelliJ set up right now, because as we bump back and forth between JDT versions, it gets a little confused. So, but the end result of all of these is that we're building J expressions from things that don't have a J prefix, which means they come from the JDT. I really would like to see what this says here for why this changed. We might have to do it from the command line instead. Not quite sure what's up there. Let's do this. And see what has actually changed here. Okay, so first of all, we've got a check to say this type declaration that came from the JDT. If it was a record, throw an error, because we're not going to be able to compile it correctly. Probably his own cleanup here for switch case. Yep, we're making sure that your switch case, if it's an expression, we're going to go ahead and throw. So it's a small white space cleanup. And here's the real error message to say if you've got a case, if it is an expression case, we have to throw about it because we don't yet support this. And then the actual structure of this case statement has changed. And we look for expressions. So we used to say pop the old constant expression because it has to have one inside the case. If the case expression is null or the case expression is an enum, is not null and it is an enum, then we take the enum and we rewrite it to a method called enum.ordinal, which is just going to be the number itself. Enums in Java have an ordinal value, which is 0, 1, 2, 3, 4, 5 for each enum, and that is how That is how we rewrite this to say, hey, if you have a reference to an enum literal in your code, we're just going to go ahead and write the number in the switch case for the JavaScript, the generated JavaScript. And now this is rewritten to say if constant expression is null, we push a null. Okay, because now you're going to have a switch on null. So I think this is technically wrong because this is now a Java 17 feature being added. But we have to handle null cases here and there. And then we have to grab each constant expression and make a new case statement. Right, okay, so the structure has changed. Can we pull up the JEP again for this? This is for switch expressions, yeah. And then look at the JEP. And the JEP calls out that we could have had previously case Monday, Friday, Sunday, and then you go ahead and return one number. And now you can have multiple of these in one. So while this pull request is not adding support for doing things like this, just by updating the JDT version, we have to be able to support this. And so what he's done here is said, grab each of those constants and synthesize a separate case block to put above this code here. And let's see, he makes a case expression, he figures out whether it's an enum or subtype, creates the ordinal, and then he pushes each of those case statements. That seems weird to me that you push all of them. I don't know if that's going to make sense. I'm not really going to worry about it too much because we'll get a block afterward that'll take care of the rest of this. We'll get good tests, though, that'll handle this. And I thought we had to do this switch also. I thought we had a switch expression we had to handle now. A new type in here called switch expression. But maybe I misunderstood. IntelliJ is really not happy and not letting me use the keyboard to control things. I have seen this happen with OBS before. I don't know how OBS does this, or what it's doing exactly that prevents my focus from working. But it doesn't look like I'm able to do anything inside this window here. I can edit a different one, but I can't edit this one. So let's try that again. There we go. Okay, I was looking for switch expression. Here's switch statement. Here's switch statement. Here's in the case statement that we have this change here. So it could be that the JDT changed from when they first introduced this feature. And that's what I'm confused about. There's no switch expression we have to handle here. Just a switch statement. Can't say that I understand why this is different. We previously built all these features, or at least the ones we had working. We previously built them with an older version of JDT, and it doesn't apply here now, I guess. So let's go back to looking at other changes. We looked at the AST test. We looked at text blocks, we looked at sealed classes, make sure that we can actually assign them, and then that's pretty much it. As long as we can assign them, we're happy. Check to make sure you can't create a new type called rectangle that extends shape, because shape already says, I only let these two things extend. And that gets caught inside JDT itself. It never even makes it into the GWT side of things. And the compile just fails. Your own Java C should fail too. Switch expressions not supported. We just want to make some switch expressions and make sure they don't do anything. And then records, I think, also are going to get a test to say they're not supported too. The other side of tests we have is this test here, where we build actual Java, and this is the super source for it, so let me open the correct one. Sorry, this is the super source for it. So now this is actual Java 17 we're writing in a Java file and making sure the compiler can read it. So my IntelliJ isn't real thrilled about sealed and permits, but that's probably because I have the wrong source level set. It doesn't seem to mind this, though. That's good news. And then basically we're saying, if I actually use these things in anger, do things make sense? So text blocks and sealed classes, do they work? You can't write new code that wouldn't compile, like the rectangle. And you can't write new code that wouldn't be able to be processed, like the switch expressions. So we just skip all that in this test here. As new things are added, they will also get added here. Okay, yeah, I think that's that. So I think this is merged up to date with the other changes I've made, and I believe the tests are all passing here. So once my branch lands, he will have all this stuff working here. It looks like just the records need a test. So let's add a comment on the pull request to say, hey, your records should also have a test. Easiest way here is to go to the epic and then go to updating JDT. And then there's a linked pull request. I may already have a note here saying, hey, let's add the record test. I'm going to go ahead and, nope, he needs to fix that. Oh, he's already fixed it. It's outdated already. I think we'll skip that because it's silly. It's weird that it didn't autocomplete because it's silly. There we go. Not autocomplete, caption. Okay, we were going to look at the... So he's got a whole bunch of these other changes that I made that need to be landed separately. I want to just look for the Java 17 AST test. Here it is. Nope, that's not it. Here it is. And I think we want one more test for... Oh, here it is, records. Okay, so I just missed it. I just can't read. Sealed classes, sealed classes. Records not supported. Okay, here we go. So this is the new record syntax, where you can basically declare a immutable bean with a one-liner. You name each of the properties it's going to have, you give them their names, and it goes ahead and generates the code you need. And then you can go ahead and construct it however you want. But they're immutable. They don't have setters, and the getters are named exactly for these things here, but without get on the front of them. So any code you've got written that handles beans by reflectively looking and saying, well, it's got a get prefix and then the word itself, that needs to support records, which will not have a get prefix on their properties. And then here's the switch expression, which will one day work, but doesn't yet. Okay, cool. Then I don't have anything to complain about there. We just need to merge my code, and then we can move on. Here is my long-running build here. We are 24 minutes in, so we got like an hour to go to run all the tests. So we can build a new language feature here. Oh, we've actually got some tests scrolling through and working. Nice. I know he's got the instance of basically done. I know that the record stuff has previously been started. That might be fun to try to wake back up again and see if we can get the record stuff working again. As I recall, that is a lot of messing around. So that seems like a decent place to start here. What's the issue for the record support? Let's see, this is this pull request, which links to here, which has the whole epic, which has records. Here. Okay, this is 9894. Make sure nobody's making noise that I need to listen to. Nobody else is making noise. Okay, I think that someone said that's nonsense, we should ignore it. Cool. 9894 records. We'll just call it records. We'll call it records tests. Branch move 9894 records. 9894 records test, because I'm going to want to run nightlies on this inevitably. Okay. So before we get started here, let's take a look at what changes we made way back when. There we go. I've switched to ZSH recently, and the git autocomplete is just outstanding to figure out what I meant. When I start typing some branch, it's like, oh, here's a branch that's got JDT in it. Maybe that's what you meant. So here is the branch where we were playing around last time. We've got some hello class that we changed in the sample. We have a record type that we deleted code from. I guess here's where we added a bunch of code. Rough draft of record toString, cleaner toString, hash code equals refactored field accessors. Okay, so let's look at the JEP real quick and see what kinds of stuff we got to think about. Records were proposed and then delivered, and then refined, and then delivered, and then we've got more changes. Is this the second preview? Yeah, second preview, and then this is the third. This is the final one. So Java 14, Java 15, and then Java 16 had the real thing. Java 17 is the version we're adding support. Canonical constructors were required to be public. In the second preview, the canonical constructor is implicitly declared. If it is implicitly declared, then its access modifier is the same as the record class. If the canonical constructor is explicitly declared, then its access modifier must provide at least as much access as the record class. As the enclosing class? Anyway, it doesn't matter. I see they just use as the record class to mean the type that is labeled record instead of class or interface. The meaning of override was extended to include the case where the annotated method is an explicitly declared accessor method, the record component. Okay. To enforce the intended use of compact constructors, the ability to declare local classes, local enums, and local interfaces. So I guess inside the record, that makes sense. And then finalize with one more refinement. Relax the long-standing restriction whereby an inner class cannot declare a member that is explicitly or implicitly static. So this means if you have an outer class and you have an inner non-static class, you can't make something that's static. This will become legal, and in particular will allow an inner class to declare a member that is a record class, since record classes need to be static because otherwise they have to close over the outer class. They have to have a reference to the outer class. That's interesting. That kind of snuck in there. Okay, so let's look at what we got here. I have read this, but it's been a very long time. This is our, hey, beans are awful, why do you write Java like this, right? I'm assuming that, you know, at least 3 of the 5 people watching write Java. And I don't think you can write Java for very long without realizing it's got a lot of dumb parts to it. The good news is IntelliJ can generate at least this for you automatically. The bad news is you still got to check it in and say it's generated. The other good news is that something like Lombok exists to say, hey, I can just go ahead and pretend you just declared this and then build the rest. The bad news is Lombok is an incredible pain in the ass. Developers are tempted to cut corners by omitting equals. I can't say that happens to me all that often, but whatever. Maybe I'm just a better developer than they're talking about here. That's probably not what's going on. Record classes are a new kind of class. And now you can just define this, and you magically get 2 members, a public accessor method with the same name and type as the component. So in other words, you have an X method, X parenthesis and Y parenthesis. Canonical constructor whose signature is the same as the header, which is to say new point, and then you pass in 2 ints, which assigns each private field, right, so it generates private fields. That way the accessor methods can return those fields. Equals and hash codes, which ensure that 2 record values are equal if they are the same type. These are final classes, so they're always going to be, and contain equal component values, x and y, and a toString that returns a string representation of all the record components with their names. So this is pretty much saying, what if you could do this in a one-liner? Because this is all obvious. You have a method that creates these. They assign private, final, and then you've got public, or at least the same protection level as the class itself. And then because we extend from object, these should be marked as override. You're a bad person for not marking them as override. Whoever wrote this, Gavin Bierman, we're watching you. And then you get the basic implementation. Because these are primitives, we'll go ahead and use equal equal. The Java 17 pattern should be used here instead, because you can just say, oh, not instance of point P, and then you don't need a cast here. This feature and all of its discussion predate the pattern stuff, so, you know, cut them some slack. Jeez, you guys. Constructors, let's see, how do the constructors work? There's implicitly declared fields, implicitly declared canonical constructors, so you get this one automatically, but you can declare them if you want, I guess. A normal class without any constructor declarations is automatically given a default constructor, which is to say no arguments. In contrast, a record class without any constructor declarations is given a canonical constructor, not a default constructor, which has all of its constructor arguments. Canonical constructor may be declared explicitly with a list of formal parameters which match the record holder as shown above. It may be declared more compactly by eliding the list of formal parameters. Interesting. Okay, so you can either list them all by writing it yourself, or you can skip them, and you now automatically have access to those as if you did declare them. So the good news is this is JDT's problem. This is not our problem. The JDT is going to go through and it's going to pick those pieces out, and it's going to say, well, it doesn't really matter what you declared it as. The point is that it has a constructor, and the constructors have these things, and the constructor has this body. And then it says to GWT, what do you want to do with the body? And we need to make sure to grab the constructor and grab the contents and do something with them. We might not be doing that right now. This is going to be an important thing to check. Let's see. In a compact canonical constructor, the parameters are declared implicitly, and private fields corresponding to record components cannot be assigned in the body, but are automatically assigned. So there's a magical super call or something here that will go ahead and assign these. But what about the non-compact form? Here we go. It's equivalent to this, where we say numerator, denominator. I guess it makes a local for GCD. Then it assigns, it normalizes the numerator and the denominator, even though something else was passed in. Oh, and then it can do its own initialization. Okay. Record classes with implicit. Wait a minute. Why did it reassign? Oh, I see. It's just reassigning the parameter. That's fine. Record classes with implicitly declared constructors and methods satisfy important and intuitive semantic properties. Record T1 through Tn. If an instance of R1 is copied by doing this, then assuming R1 is not null, it is always the case that that one equals that one. Cool. It is not generally possible for the compiler to check that explicitly declared methods respect this invariant. What does that mean? Explicitly declared accessor and equals methods should respect this invariant. Okay. So if you are going to do something naughty and either make your own constructor or your own equals, you should make them follow this. This is kind of the same rule about if you implement comparable and you just decide to make comparable not match equals. Weird stuff's going to happen, and that's on you. Don't be that guy. As an example, the following declaration should be considered bad style because its accessor methods silently adjust the state of the record instance, and the invariant is not satisfied. So we get the default constructor, but sometimes instead of returning the proper x, we will return 100, but this doesn't violate this constraint. Oh, it does violate this constraint, because when you call x, like if you called r, or a small point x, if you called this constructor with another instance and you called x for the first parameter and y for the second parameter as sort of a copy call, you would read, instead of, 50 here, if it was 50 here, you would return 50, and that would be correct. If it was 150, then you'd return 100, and the new instance would have 100 as its values. And equals would say, well, 100 is not the same as 150. These two instances are not the same. So you should have an equals method that normalizes that. Because the equals implementation is going to access fields. And we want that because that's more concise. Okay, rules for record classes. There are numerous restrictions. A record class does not have an extends. Okay, the superclass is always Java Lang record. This has already bitten a bunch of people. Anybody who has in their project a record type now has an automatic record type in Java Lang, which doesn't need an import. So if you have been referencing, if you have two classes in the same package and one of them is called record, the other one now needs to import that class. Similar to how the superclass of an enum class is always Java Lang enum. Even though a normal class can explicitly extend its implicit superclass object, a record cannot explicitly extend any class. A record class is implicitly final and cannot be abstract. This basically means that all of your methods are final too. The fields derived from a record are all final. The restriction embodies an immutable by default policy that is widely adopted for data carrier classes. Okay, so the one gotcha about this is when everything is immutable, to change things, you need to copy the whole thing. And that isn't always cheap. JavaScript is kind of getting their head around this with the, what's it called? Where you use ... I know the word, I just can't remember it right now. Nope, can't remember. Anyway, where they're basically saying, hey, take that object over there and grab all of its properties and pack it into a new object, except I want this one thing to be different. Which is, super fancy and nice to say, just copy all that stuff. But then people do it for arrays because it's a really nice way to say, hey, just add one more item at the beginning or one more item at the end. And you do that 10,000, 50,000 times, and suddenly your code is slow and you don't know why. Immutability has this problem. They are considering in Java 23, I think, adding utility methods to make records automatically be able to change properties. So you say, it's like a builder kind of thing. You say small point dot width x, and you pass it a new x, and it will return you a new record with the old y and the new x. This is common in builder pattern stuff too. A record class cannot explicitly declare instance fields and cannot contain instance initializers. The only fields you get are the ones that come from here, and they're always final. Cannot explicitly declare. So you can't say, I know it's an int here, but I'm going to make it a long internally or something. That's interesting. An explicit declaration of a member that would otherwise be automatically derived must match the type of the automatically derived member exactly. The good news about all this, again, is that the JDT is going to catch it for us. We still want to go over it and make sure that if there are cases where someone can replace one of these things, we got to make sure that we're calling their instance. And we'll see a little bit of that in the implementation. And the explicit implementation of accessors of the equals or hash code must be careful, should be careful, to preserve the semantic invariance. Which is to say, you don't have to. The compiler won't catch you if you don't. But your stuff won't behave the way you expect. You cannot have native methods. That's great. No class with native methods is likely to be a good candidate for migration to a record. Interesting. So they're saying that if you've got a struct in C, I'm doing a little bit more, unfortunately, C, interacting with Java these days. If you have a C struct, you should not map it to a record. It just doesn't make sense. There are Project Valhalla coming for Java. Will give us some fun things like that. But basically, they're saying this ain't it. Don't try and use this for that kind of a thing. Beyond the restrictions above, a record class behaves like a normal class. Instances of the record class are created using a new expression. Yep. They can be top level, nested, and generic. So all your pair classes out there should be records now, basically. A record class can declare static members. It can declare instance methods, so you can have a comparable, I guess. Oh yeah, because you can implement interfaces. Cool. So you can make a compare to method. You can make a plus method if you make some vector record, X and Y, and you've got them pointing in different directions. You can, oh, that's not how you do camera. You got some record pointing this way and you add some other record like this, it's going to take this record here. You can go ahead and say there's a plus method that handles that. A record cannot specify a superclass. A record class can, however, freely specify super interfaces and declare instance methods to implement them. Just as for classes, an interface can usefully characterize the behavior of many records. So you can have the same interface implemented by many records. The behavior may be domain independent, like comparable, or domain specific, in which case records can be part of a sealed hierarchy. Remember, we saw that earlier. So you can have one sealed interface that says, here's the different things that are going to implement this, and it just so happens all of those are records. That way they're all immutable. You don't have to provide methods in your sealed interface, and you can just say, this is sort of a union of those types. This is the closest we're getting in Java to type unions, I think. But sealed does get us there. You can give it a named type union. We have been playing with generating TypeScript types for GWT, and we have been using the the elemental examples of type unions, but it would be really nice to say, hey, here's a sealed interface, and the sealed interface now is the type union. It represents the type union. So that's something I'm really looking forward to. Because right now I've got to write like 6 lines of code for each possible subtype that you could be. You got to have an is, and you got to have an as method. Anybody who's used Elemental has ever had a getter that accesses something on style, and it might return a string, and it might return a number, has had to deal with this craziness. A record class can declare nested types. So that just means as we are visiting the JDT types, we have to go nested in and look for more nested record classes or other classes. If a record class is itself nested, it is implicitly static. This avoids an immediately enclosing instance which would silently add state to the record class. It would close over that. A record class and its components in its header may be decorated with annotations. Okay, I don't know what that would be interesting to think about. An annotation on the record components are propagated automatically to its derived fields. Okay, that is interesting. So if you put something on here like a JS property, it will automatically propagate to here and make this a property instead of a method. That's kind of cool. We're going to have to make sure we get that right. Annotations. Here we go. Type annotations on the record components are also propagated to the corresponding type uses. Nobody uses type use, but you still have to know how it works. Instances of record classes can be serialized and deserialized. However, it cannot be customized by write object, read object, blah, 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 blah. Good move. That's all trouble anyway. A local record class. A program that produces and consumes instances of a record class is likely to deal with many intermediate values that themselves are simple groups of variables. So this is how Java's going to say, we're going to deal with multiple return. Basically, we've got tuples. You can have named tuples with strong types. It will often be convenient to declare record classes to model those, because it's a one-liner, right? You just say, I've got 3 things I'm going to return, and then right inside of here, as I'm building this, you say, I need merchant and double, and I need both of those to be processed. So grab whatever this thing was here, map it to collect both its merchant and some number. And I can't even tell you how many times I've done this, where I've just had to say, give up and use a loop instead. Or do something really dirty like map.entry to contain both of them. and then you sort based on that sales. So we need to say, I don't just want the sales number, I want the sales number and the merchant, because in a minute I'm going to go ahead and just peel off the merchant. But in the meantime, I'm going to compare the sales values. This should have been a comparing, I think. But whatever, that's, you do you. Local record classes are a particular case of nested record classes, true. Like nested record classes, they are implicitly static. This means their own methods cannot access the enclosing method or type. In turn, this avoids capturing an immediately enclosing instance, which would silently add mutable state. They don't say mutable, but they mean it. To the record class, the fact that local record classes are implicitly static is in contrast to local classes, which are not implicitly static. In fact, local classes are never static. You can never make them that way, and can always access variables in the enclosing scope. So I think the main takeaway for that is we need to test this. We need to test this case where you stick one of these in a method and make sure they actually work the way you expect. They need to compile to a top-level class. In Java bytecode terms, those will live in their own file. And then you can use them however you want to. They will be accessible by everything in this type. Shouldn't mean too much for us. It also means that very rarely would your record that you define in your method ever have contents here, I think. Because pretty much you should just be using this to mangle fields, or just to say, hey, I need this and also this. You should just be doing a quick wrap and unwrap kind of a thing. If you need more than that, you're probably holding it wrong. That's my editorializing, by the way. There's nothing in the spec that says that has to be true. Local enum, local interfaces. The addition of local record classes is an opportunity to add other kinds of implicitly static local declarations. Nested enum classes and interfaces are always implicitly static. Okay. For consistency, we define local enum classes and local interfaces, which are also wait, hang on. Nested. Oh, I see. Nested versus local. So for consistency, we define local enum classes and interfaces, which are also implicitly static. So this is, hey, as long as we're writing this feature, let's sneak in changes to the rest of the spec again, which is a good idea. It is consistent, but it is, might surprise you while you read it. So it's possible that we should add some extra tests here to make sure that we can do local enum classes and local interfaces inside of a method and make sure that that works properly. Static members of inner classes. It is currently specified to be a compile time error if an inner class declares a member that is explicitly or implicitly static. And this is the thing where they relax the restriction. Okay, cool. So this is pretty much going to be a JDT problem. We don't really care about it. But we will have to make sure that we can support it, that nobody, left out a check for, hey, is that thing a thing that I should make into a field? Something like that. Annotations on record components. We talked about this already, I think. They have multiple roles. Record components have multiple roles. They make fields and they make methods and they are arguments. An accessor, this raises the question, when a component is annotated, what is actually being annotated? The answer is all of the elements to which this particular annotation is applicable. So that's kind of funny because it means you can use my annotation, which is only meant to apply to a field, on an argument. And I suspect that reflectively, it won't be available on the argument. But it will be available in the field, but not on the method. So if you had one that was only meant for field, this declares that the annotation I1 is applicable to fields. We can declare it as applicable to more than one thing. Great. This declares it as applicable to both fields and methods, but not parameters. But you can still put it on parameters. If the annotation on a record component is applicable to a field declaration, then it appears in the field. If it's applicable to a method, then it appears in the method. If it's applicable to a formal parameter, then it appears on the corresponding formal parameter of the canonical constructor. Oh boy. If one is not explicitly declared, or else to the corresponding formal parameter of the compact constructor, if one is explicitly declared. I'm a little stuck on formal versus compact constructors still. We might have to play with it and see what happens. Try it out a little bit. Because I don't think we care about the distinction there. but it's possible that the JDT will give us some of that to deal with ourselves. If it's applicable to a type, then it will be propagated to the type of the field, the return type of the accessor, the type of the formal parameter, the type of the record component. Oh, that's interesting. So you can not only ask a record, hey, what fields do you have, but you can also ask, hey, what record components do you have? So I guess class itself has been changed. Let's look at that real quick. SDKs. Let's kick this up to, I don't have 21 set up. That's not at all what I meant. Where's the path for this stuff? It is roughly, funny, 18 is 17. That's super useful. Let's do another one from user bin, user lib JVM. And then we want 21. And this is probably going to briefly get grumpy. All right, looks like it's done. Let's look at class. That is the 21, or the 19. I wanted 21. Didn't we just say we wanted 21? Is there a different place I got to change to say I want a different JDK here? Oh, here we go. Indexing. Get record components. Cool. So there is a new thing on class itself to let you access the record components. And they return record components which have a class name type accessor, signature, annotations type annotations, blah. Cool. Okay, so that is a change to class itself, Java Lang class. If a public accessor method or non-compact, this is really quite a big feature. It kind of surprises me we actually got this done in as little time as we did for the draft version of the JDT. But there's a lot of stuff happening here, and it sprawls across quite a bit of Java. It's not going to break anyone's existing programs, which is probably why they were so careful and so slow to let this out to begin with. I mean, it took them 2 years. Took them 2 years of changes, right? Because they released it in 14, and then in 15, and then in 16. Anyway, if a public accessor method is declared explicitly, then it only has the annotation which appear on it directly. That makes sense. Nothing is propagated from the corresponding record components. So if you make your own methods, you deal with your own annotations. For the most part, annotations aren't going to apply when you are writing your GWT code, except for things that GWT itself accepts. JS interop, unchecked cast, things like that. Please don't use unchecked cast in your own code. The annotation unchecked cast. Okay, compatibility and migration. The abstract class Java Lang record is the common superclass of all record classes. Every Java. Why did I add 21? I should have just added 17. I don't know why I added 21. Well, whatever. It's done. Every Java source file implicitly imports Java Lang record, as well as other types in the Java Lang package, blah, blah, blah. So this will break your own record. We've already talked about that. It's not very interesting from our perspective. It's just important to note as a breaking change. So, kudos to the JEP crew for putting this together, but it doesn't affect what the compiler needs to do to get this done. Java grammar. Okay, so here's what you can do to it. We can make a record declaration is public, sealed, whatever. the token record, the name of the class, the type parameters, if any, the header, which is the parentheses list of arguments, any super interfaces, so extends, blah, 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 which will be declared in another part of the grammar, and then the record body. And the record body is an optional record body declaration, which is a class body declaration plus a compact constructor declaration. Okay, so here we go. The class body declaration we should look at to make sure we get that right, but you can add a constructor modifier, a simple name type, and then a constructor body, but you don't put the types. You don't have arguments here when you do a compact one. A record component is what is passed into the component list, which is part of the header. Here's the header. The header is the list. The list is components. The components are annotations, type, identifier, or you can do varargs. You can say annotation, type, annotation on the vararg bit, and then the identifier. Okay, class file we don't care about. Reflection, oh, hey, here it is. Get record components and is record. Alternatives, tuples. Yeah, okay, cool. They call out tuples specifically. Names matter. Remember, we got to be super verbose in Java. We got to be really, really specific, which is a design philosophy you may or may not agree with. If you're here, you probably don't care too much because, you know, welcome to Java. But there's reasons that we do that. And the reason is we want to come back in, 10 years and be able to read our code and tell what's going on. You don't want to have, oh, well, we just returned false, and then maybe a string to go with it that tells you why we returned false or whatever. We want to say it's an error. Is it an error, true or false? And then what's the error message? Or it was successful, true or false, and then here's the value I got back. Classes allow for some state validation through their constructors. Tuples typically do not. Right, that makes sense. If we just had syntax where you did curly braces and then two values, it's harder to put the, hey, does this make sense there? You've got to have some other utility method, a factory method or something that creates those. We want to push you in a direction that makes it easy after you have declared the tuple or record type to add additional validation. There should be a simple way to add new validation. I like that. Classes can have behavior that's based on their state. Co-locating state and behavior is a good idea, generally. Dependencies, sealed expressions will make, or sealed types will make this very nice. We already support. Algebraic data types or type unions. Oh no, type products. Yeah, sealeds will let us make sums, and records allow us to make products. I've forgotten why a sealed class, a union, is a sum. It's like that type plus this type, as opposed to that type cross this type. Okay, so if you want to think about this in terms of numbers, if you've seen this before, sum types and product types. Let's say you got two enums that are in a record. You can either be, on one axis, you've got, A, B, C, D, E. You got your 4 enums over here. Oh, you can't see that. And then let's say you got 3 over here, X, Y, Z. So basically you've got 12 states. We're multiplying the possible states of each field that goes into the record. So there's 12 possible states you could have here. Sum types, on the other hand, let you say, I've got this enum that takes 4 values, and I've got this enum that takes 3 values. If I union them, you can return any of these 4 or any of these 3. So now you can return the sum of these 7 values. And if you combine records and sealed types, you can now say, well, you can return a point with its arbitrarily many, X and Y, or you could return a vector, or you could return a rectangle, or you could return a circle, but only those types. And so add up the possible states of your various sum types into of your various product types into your one big sum type. So if that helps to think about in your head what it means when people are talking about product types and sum types, it seems like one of those topics that's someone is really deep in type theory or something magical like that. But really, this is a very simple concept. You just need to think about the possible states that can exist in your program, which is a really, really good habit to be in. It lets you avoid bugs by imagining that those states could be. So going back, for example, if you've got 4 enums here and 3 enums, you've got 2 different fields, and each one's an enum. One's got 3 states and one's got 4 states. Do you really need all 12 states, or are some of those impossible? If some of those are impossible, maybe there's a better way to phrase your type. In addition to the combination of record classes and sealed classes, record classes lend themselves well to pattern matching. So do sealed classes, actually. Because record classes couple their API to the state description, we will be able to derive deconstruction patterns, which is in, I don't think 21 got it. I did link the other JEPs here that are coming in 21. Record patterns, yeah, we did get it in 21. So really quickly, before Java 16 you could do this, after Java 16 you could say, well, if you've got this, then just grab the S. And what if you've got point P, something instance of record point P? Now you need to decompose these one line at a time to grab the actual values. But what if instead you had object instance of point, and if you're watching, you're going to hate this. What if you could decompose this and say, if object is a point, just go ahead and assign new local variables x and y for me. Let me say, grab that value out of the DOM or from the server or something, and then now that I know what type it is, because I did an instance of check and it passed, now I have x and y as locals, and I can directly interact with them. Because this is just garbage you have to write in Java right now. If you've come from another language or ever had exposure to Haskell, this is sort of second nature for a lot of things, to decompose things like that. It makes a lot of code a lot simpler. So if you start nesting them, you can have records inside of records, and then you can decompose the point and the color of the record inside the record and start doing things with them. And I think they've got an underscore idea here to say, I don't actually care about the color, I just want to get the point out. Let's see what they did. And if they fail to match, then you're in the else, and you don't have access to those. No, I don't see the underscore, though. So maybe they didn't do that. Exhaustive switch. This gets tricky now, because if you've got P1 is pair A, and pair A is B extends A, so these could be AB or BA or AA or BB, is what they have built up for us. I guess. Oh no, it's worse than that, I'm sorry. These two switches are exhaustive since the interface I is sealed. And, oh yeah, then they switch to sealed instead to say, now we can guarantee you only have these possible C and D. BA and AB, AA, BB, BA, BB are not sufficient here because someone else in their own code could subclass B or A further because these are not sealed. Because this is sealed, you can say you can't go any further than that. All right, is this a preview? This is done. This is delivered. Cool. That's gonna be a fun one. It's gonna be more work to do, but it's gonna make some specific kinds of code much easier to write. And then pattern matching for switch is another 21 feature. That way you can do the same things in your switch cases. So you can already say, hey, if it's an instance of string, we can do things, but now you can say when. That way you can branch on if it's a string and it equals that. Okay, that's not really what we're after here. What we're really here for is to decompose your record. Here we go. Oh no, this is an enum type to say, okay, well, if it's an S and it happens to be that suit, I don't know why you would have, oh, you'd have other non-suit things. That's kind of silly. You can do it with records to show us. Anyway, we're a ways off from needing to worry about this. This is more label junk. Type checking stuff. Record point. but it doesn't decompose it yet. Huh, I thought we had record decomposition in here too. What's special about this? Why do we need to declare it integer j? Oh, because now you can get the actual value j as a locally scoped variable. Okay. But you could also just say I. There's a reason they didn't want to do that. We'll have to dig in and figure out why that is. Another day. I'm just going to search this for records. Doesn't look like they're going to dig in here with records. Yeah, here we go. This is what I'm after. So you can grab the value out in your switch case. So you can just say switch on union of records, figure out each of the different record types and what their values might be to return other fun stuff. And then this is future work, it says. General class will be able to declare deconstruction patterns to specify. Okay, so maybe this isn't really in yet. Okay. Well, we'll deal with that in the future. Let's go back to actually pulling some of this code out so we can use it. So we've got this object methods type. But we don't. I guess I haven't made it yet. This is a new class here that is part of Java Lang runtime. Really? So we probably have to define this even if we don't use it. Yeah, it looks like some of this method handles stuff. Okay, so let's take a real quick look at that. I don't really want to switch to that branch because I don't think it's going to merge cleanly. Well, let's try it right now. We'll go ahead and cherry pick some specific stuff as soon as this gets caught up. Okay, so that's it. That's the full implementation here. We have to provide that to get this to work at all. And then a record itself, as of the tip of this branch, is quite simple. It previously in this branch had some helpers, like this toString thing, to say, well, we know the type name and we know the labeled components, which is to say the label equals component. We'll look at what that looks like. And then I guess I rewrote it that way we did not need to have a utility here with an extra array constructor, but can just directly build them. So let's look at what else is in our history. I don't want to say anything too loudly, but it looks like IntelliJ got its head out of its butt and it's working properly now. That's an example. Yeah, okay, so here comes the headache. You ready? If you've got a record and we're translating your JDT type declaration, JDT type declaration into a J declared type, if it's a record, we have to add certain record methods that may or may not exist from your own writing. So here's write record methods. This is a record type, and any methods that were declared but not referenced now need to be defined. Declared but not referenced. Declared but not referenced. What does that mean exactly? If it's not referenced, why do we need to define it? These include field named method accessors, equal hash code, and toString. If not defined, we'll synthesize them based on, which means this is probably backward, that were referenced but not declared. This is probably just backward. If not defined, we'll synthesize them based on the record components. So for each method, if there is a body, that means the record has its own declaration of the method, and we should not redeclare it. Now we've got this toString method name, which is just, toString. And if it has no parameters, then it must be the real toString. But we know that it has no body, because if it had a body, we would have returned. But if we happen to have found the body in the J declared type, oh, I got this backward. Nice. We're looking at the J declared type, which is the GWT AST type. And for some reason, it was told, hey, you've got a toString method. It doesn't do anything. So now we need to say, oh, okay, wait a minute. toString has to actually do something. So now we're going to rewrite that. Let me go ahead and open the real one here. This is going to be really hard to read. I thought this was a lot shorter than this. I mean, it took me a while to get this right the first time. We're going to get the annotations up over here, and then we're going to get record type. Okay, so here's the same implementation, but a little bit less garbage. To build our toString, we start off with curly brace, our type name, plus curly brace, and we're going to make that into a string literal. Oops. Okay, now it's being dumb again. Here we go. Type name plus curly brace, and that's going to be a string. We're going to concatenate that with each of the fields, the field name and the field value. And there's this little equal thing I guess we're going to do here. And I've written the loop code here. But remember, this is the compiler. So there's going to be no loop at runtime. This is just going to say, I know all the fields you have. So let me go through each field to grab it, take its field name, equal sign, and then take that as a string literal, which means if you have point with int x and int y, this string literal here added to the compiler is going to be x equals. And then there's going to be the actual reference to the field x. And then it's going to be y equals, and the actual reference to the field y. So we've got this whole chain of expressions that we're going to go ahead and add together. The type name, the curly brace, all in one string, and then each of the parameters, each of the fields, and then their values. And we're going to join them together with plus, which for some reason we distinguish from plus by saying concat. So there's concat, and there's also plus separately. Add. There's add and concat. Those are different operators in GWT. Fun fact. Then we build the method body, and we say take that whole giant type name plus first field value, plus second field value, and then end it with close curly brace, and make that into one return statement. So it's return string plus string plus string plus string plus string plus string. And that's now the method body for toString. So this generates a very simple toString method. And then likewise, we've got equals here, which again is predictably named. If method params is 1 and the return type is Java-Lang object, we know we've got the right one. We make a method body, just like last time. And then we need to first do an equality check of types. Oh, I'm sorry, equality check of this instance and that instance. And then we do my record and their class. And this is just the AST nonsense to say in data structures, how do we build up that code that'll eventually get printed out? This is wrong and not optimized automatically, but it is resolvable without waiting for a later visitor. To do, replace with object get class instead of cast get classed. I wish I had written down why it was wrong. Anyway, this is the, hey, what class is this object? Typed other, create a local called other. Okay, so this is now where you say, now that I know that our two objects are the same type, go ahead and assign that to other. We should replace this with pattern matching instance of, like we already talked about. Block, get, block, add statement. So this is now going to be our assign, where other equals the other one with a cast, and then we and all of our field checks together. Take each non-static field, check to see if my field equals their field, which is this super long thing here, and chain that together in a big list, and then join them together with and. So for each field, make a my field, their field, my field, their field, my field, their field, so on and so on. And then join them all up together with a giant and wrap it up in a return statement. Hash code is simpler because it's missing its body. Oh, no, it's not. It's using objects hash, which we added in this. So we've got objects has a hash that takes an array of objects, which means it's going to box primitives. That's not ideal, but whatever. This is just a very simple way to say grab all the fields and jam them into this one big call. And then if you have no params, we're going to see if you happen to be one of the record components. If so, generate a new field reference and make a return statement from it. So this synthesizes each of those. I don't know where the constructor gets synthesized. So that'll be fun to look for later. Okay. Let's look for more. I want to see the record constructor, because something must be doing record construction in here somewhere. Okay, so this is another big block of code. If X is a record, then we need to look up something. I never really understood this. You call get on these things. Anyway, this get call is not actually like a map call. It's a go ahead and resolve whatever that is. And we need to say, make sure that these things exist because someone might be calling them. Either because record declares its own or we make our own for it. We just need to make sure a binding exists. So this is like this must be the, hey, something needs to reference this at some point. It's still not the constructor that I was looking for. Create members, that is not record specific. This is just to make sure all those things exist. Yeah, I don't know what creates the constructor. Unless the constructor is created by JDT and we visit the JDT version of the constructor and that assigns the fields for us. Yeah, I don't know where that exists, so we may have to dig in there and figure that constructor bit out. Okay, so I'm just going back in here a little bit to say where should we start cherry picking from. This was modified so that we could actually see the generated code that was happening, which is probably a good idea. But I really just want the working stuff for the moment, and then we'll build good tests later on. So let's start with oops. Yeah, this is where we want to be. We're going to cherry pick these commits in order and resolve conflicts as they happen. That has already been resolved in this branch, I think. One change in this file. I don't know. Oh, I see. I already changed it in something else. We might need to update that again. Okay, so the Java 17 source has been added. The test is added. ASM, so Java 17 works now, has already been done. Sealed classes. Broken deliberately. First try with the record. So we'll start on this commit here. And then we'll grab emulation. Just going one commit at a time. Handmade record, we're going to skip that. Emit and bind synthetic methods for records. Oops. I lost the position of the scroll. First try with the record. Add missing emulation. Handmade, emit, and bind. Rough draft of toString, which we're just going to junk right away because we got a better implementation. Cleaner toString with hash code and blah, blah, blah. And then more testing. And then we'll probably just grab the result of all the testing. Okay, so now we've got, oh, the hello stuff. I guess we don't want that. Let's go ahead and revert whatever we got in here. We'll rewrite it later on for our own testing sample junk. This was streams like a year and a half ago. We were testing this stuff out. So I guess I accidentally grabbed the wrong commit. First try with a record. Yeah, I guess so. All right, the rest seems to have picked cleanly. Any bets that this is going to build? I bet no. I bet something broke. I bet the ASD changed. Yep. Oh boy. Oh, I got the wrong tools checkout, I bet. Yeah, here we go. So his PR is this one. Yep. Let's try that. This is the scary one here. We'll see what that does. Cool. Looks like it worked. It's been a while. Let's see if that nightly build is done that we ran before. Yep, it passed. Cool. This is the wait a long time part. But by and large, things seem to be working, so we might get away with it. Let's try next to make our record here. We should grab the document that we worked off of before and see. Where's the JEP for this? Is this records? That's switch. This is the one, I think. Records, yeah. So let's build a couple of these examples. So, annotations would be fun. Let's do, I don't know. What's another thing here? So this is going to be kind of fun. We put JS type on this. This will be a property. This will not be exported, and this will be exported as a method because it's public. I don't usually do wildcard, but we don't actually have sources worked up for this. So let's just go ahead and make that. Let's tweak the sample stuff. I guess it's over here. We want to enable export, JSON interop export. Oh boy. Gwt JavaC, Gwitc, here we go. And then we want to add some extra args here. And then I think that's right. Oh, I just want hello. Okay, right. We gotta bump the source level, I guess. Or I need to actually write valid code. What's your complaint here? 38. So I didn't mind the other ones. You have to have semicolons. Let's just comment that out for the moment. See if the other ones work. No, they did not. Annotation type not applicable to this kind of declaration. That's Java-C itself having that problem. So we need to look at the Java-C invocation here and say release 17. That's right. Okay, I got the wrong one. We need to have Java 17 running. Yeah, there we go. Okay. We'll put this one back. But let's take a look at the output first, see if we got this generated type. It's not going to do anything, but it might exist in a vaguely sane way. Ah, and this is still unhappy. We probably need to specify the source level. I gotta think about where that is. We can just back it on here, I guess. I think that's right. Oh boy. Internal compiler error. Okay, so we're looking at type declarations for visiting something. So let's go ahead and fire up a debugger and figure out why our old code doesn't work with our new code. We want another JVM arg for the compiler here. We want to suspend right away. This is the kind of thing that's better done in unit tests, I think, at least for once you've got the basics working. But the first draft is always nicer to do in just an example program where we know exactly what we've got. We know we're running in a regular old environment. And it exited right away. Did I forget to turn on breakpoints or something? No, they're on. Maybe I don't have null pointer exception set to trap. I've got a couple of exceptions set to trap, but no Java exceptions are enabled. Here we go. Let's try that again. The good news is it fails fast because, like we said before, the JDT parsing happens very early, and transforming that to Java stuff is also pretty early. So we've got some null name, and we should have source info here. So hello, line 32, which is, again, much easier to read in a plain Java file than from some test code. So apparently this has no name, whatever this.name is supposed to be. It should be 0.1, it should be 0.2, person. We're in a reference type. We tried to build it. Final is false. That's weird. Final should be true. Remember, all record types are final. Visit type declaration X. Okay, so this looks like our type declaration here. We got record 0.1. Just check this over here real quick. Yeah, okay. We got record 1, point X and Y. We've got, oh cool, they've got little implicit tags in there to say, hey, this should just automatically exist. If we expand this, do we get anything more useful? We kind of do. It's weird that they omit this, but whatever. It's weird that they omit the hash code and equals and blah, blah, blah. So that's why we got to generate all that, right? I think that I'm guessing that there's bytecode that's doing that for us in the compiler. In Java itself. So now if X is record, so I'm catching Ahmed's check to make sure this works. This isn't going to work, though. we need to fix this. We need to ask for the new type declaration name. It's final. So this way we'll get a better error message, I think. It's a char array. Screw you guys. It's a char array? So where's the make that into a name code? Zachary, huh? Get string literal. I want to make this into a string intern. There's what we're going to do. Okay, so this is a commit to hand to Ahmed. I'm guessing right now he only has to check for, does this fail with a vaguely useful error? Okay, so let's leave this in place and propose our change to it after we get this running. So we're going to say suspend no. We're just going to run it. Oh, we didn't rebuild the compiler. Can we just compile it? I guess we got to build it. Yeah, we got to build it. Okay, that's going to take a bit. I'm going to take a very short break here. I've been drinking coffee all morning and could probably use something that's not coffee in my blood. And then when I get back, this should be done, and we'll take a look. Less than 5 minutes, and I'll be back. If I can get the right screen. There we go. Back in 5. We had an irritating ant issue, and it's rebuilding again. We'll see what we get. All right, while we wait for that, let's see if we can make some other samples. I think, if I'm reading this properly, these are the two forms of constructors. The conventional constructor and the compact canonical constructor. So we should support both. All right, if this works, we'll take a quick look at some of those constructor formats around hash code and equal. Okay, so this is 0.1 final records not yet supported. And it tells you here's the name of the class and that it is final. Because all records are final. Okay, cool. We will make that suggestion to Amit's patch. I'm confused that we didn't need anything extra here. But I'm sure I'll get over it. All right, we gotta do it again. While that runs, let's make some more samples. We can only validate in these compact canonical constructors. Sorry, we can normalize. You can normalize, and then after them, they will assign. Okay, so just to make sure I get this, we'll go ahead and swap it or something. I don't know, just something garbage like that. Yeah, forgot about that again. And then whatever it's assigned to at the end of the compact representation will it actually assign there. Gordon Freeman, welcome back. It's been a while. This is how you do it, right? Let's see. This is the canonical. This is the conventional. So you just go ahead and name them all. And I think that means you're going to get an error if you change the order you stick, or if you omit one. But I believe you can add other things to it also. You never been here? Oh, I thought we had another name with your provenance. Well, probably. All right, let's see. So what other, this is just the idea here of normalization or validation. All right, we'll stop there. It doesn't really matter what you, oh, except this won't compile because you have to actually assign. That's actually what it just said, great. But that's Java-C failing. Not our ideal situation, but, well, I mean, as long as GWT-C fails, we're good. All right. First try, except for all the other tries. The output gets put into staging, I think. It's been a while since I did one of these. Here we are. Okay, here's our generated JavaScript. Which type were we looking for? It was exported person. There's no person that was exported. I might have mangled the hey, you need to export this thing here. Are any of the points left here, or are they all pruned also? Yeah, not much is happening here. Okay. I wonder if the whole type needs to be public? It's been a long time since I've done this. I don't really remember how this part works. Oh, I see. You just followed too. Sorry about that. I only get that on the one view. That's weird. Anyway, welcome. I'm out of practice for streaming. It's been a few months. So what if we just make one of these things and just two-string it? Because that's part of the point here, is testing this out to make sure that the two-string and whatnot all behaves the way you expect. I don't care what the output is. I just need to see. I'll make point 1, 1, 2, 2 string, and then we'll do another one with hash code. But let's make that be a different type. Let's make that be the inner type to make sure that our JDT tweak can handle that. Should be pretty simple. Hopefully we'll see some change to the output so we can actually confirm that this is doing what we want. And then we'll figure out that export. I think I already added a public. That's the only thing I can think of that might be necessary there. All right, the compiled file changed name. There's 2 permutations now instead of 1. I wonder what the difference there is. Let's look for point 1. So here's where we're constructing those. It called the static toString. It called the hash code. So here is the code generation for toString. Does the spec actually say what toString should do? Oh, so it just has the class name itself. It doesn't have the fully qualified class name. So we should probably hack all the rest of this off. So let's go to the AST builder and look for that toString. No. Oh, I just follow this, right? It's going to be this one here. So here's where we're stitching together the code gen for it. So we didn't actually see the Java for it. It would have been kind of fun to see the Java for it. Because you can see that it, well, we got 2 curly braces in here. That's dumb. We'll have to fix that. It actually went ahead and said, well, you've already got this string here and you've got this string here, so let's just make them one big string, which is exactly what you wanted to do. Let's see, the type name shouldn't have a curly brace on it. The curly brace lives by itself, and then it looks like I added another curly brace here. So that was silly of me. So we just kill that, I guess. Now we'll just get 1, and then we also want to say, instead of giving me the full type name, we just want the simple name. This is the binary name of the type. Let's see if there's another type name we can use. There we go. Short name. Compound name is the name is an array that contains the simple name. So if we just do get short name, that'll probably be it. So that will simplify this, and then we will have our x and our y axes. Let's make sure that those resolve to something nice. Here is the toString and hash code. This doesn't look right. It should have the fields in there. Oh, I see, but hash code is a static method to do the lookup. Here's the equals. Equals is if we are equal, return false, huh? Return true. if your class literal doesn't equal that class, return false. This should be does not equal. No, if it does equal, it's a short circuit return true. Cast the other one, compare the other one. Okay, so let's fix that too, because that's just silly. Equals is here. We're going to need this bigger because this is way too long to read. If statement, return false. Yeah, so it should return true. Cool. All right, that'll fix that. Why are you scrolling? All right, that was point 1. Or point 2, I guess. Here's the toString for it. Let's look back at our sample for what we're trying to create. Point 3 would be kind of an interesting one, except it probably was pruned automatically. Let's bring it back. And then we got to figure out person. Here we go. Person is here. Okay, so we must have had stale code before or something. So we are tracking all 3 properties. This is a plain constructor. It has no equals hash code toString, it appears. Oh, I'm sorry. This is where we build its type. So the constructor is built. We build a class on the constructor, and then we assign to it to say, here's your equals, here's your hash code, here's your toString. We initialize your fields to 0. And then the name gets that. And then at some point, we're going to expose name and lat to JavaScript, but never lon. I don't know why it didn't prune lon, but that's what happened, I guess. Probably because it thinks it needs to export these things. I'm not really sure. We'll look into that more later. All right, so let's look at lon and see if something is exporting it later. I don't see any exporty looking code for these properties so that JavaScript can read them. Okay, so here's where it says, here's the chain to get the hello person. Provide is the glue this together so JavaScript can see it. So I think we're missing the code that grabs annotations and puts them on methods and fields. There's also the gotcha that if you put a JS property on this component, it's going to apply to both the private fields and the public methods. And that's not going to work very nicely. So we might want to establish a convention about that. If you put JS property on a record component, it only applies to the method, not the field. Because technically JS property can apply to both. Okay. But it is exposed, and that's the important thing. So we'll have to fix this later. Let's try this one, see if this does anything here. If x is greater than y, so we gotta make sure that x is greater than y. That way x ends up being equal to y. And then let's finish this one off here. If x is less than 100, then give it x. Otherwise, give it, I don't know, -1. We just want some kind of logic here. That way these final fields get something in them. All right, what other kinds of things do we need to build here to try out? We could do custom equals if O is not instance of point. Rather than a class literal check. All right, let's look for point 4. So it went ahead and inlined the parameters there. That's interesting. It just evaluated that it must be -1. Okay, that's not, the end of the world. That's pretty much what we would have intended. It is somewhat surprising to me that the entry point left in this 10, but inlined the 2. X here, assigned x is greater than 2, then x equals 2. I guess it just can't handle that normalization. So it inlined the 2, but because there's an assignment happening here, it decided it wasn't going to rewrite. Anyway. And then it inlined that the rest of the way. Okay. As long as those things work, and those fields are accessible, x0 and y0. Constructor already has x0 and y0. The hash code, let's go see what hash code does. Yep, x0 and y0. It is going to box those. Hash code 12. I wonder if objects.hashcode boxes them. That's interesting. I would have expected boxing code on the way in then. If A is null, return 0. Otherwise, iterate through the array and invoke hash code on whatever it was. This looks wrong to me. I think, well, I think there should have been some boxing code that the compiler should have done for us. What is doubles hash code, by the way? Because that's what it's going to do. It just casts it to int. Really? It truncates those bits? Hello? Returns a hash code for the double. This is the exclusive XOR of the 2 halves of the long integer bit representation, exactly as produced by, oops, not what I meant to do, long 2 double bits of the primitive double value represented by this double object. Thus, the hash code is the expression that XOR shift. Huh. So that's not right. That is not the correct hash code. I mean, I don't really care, but it's weird. Does Jackal do that too? I want to go to platform. Why won't you take me to the definition? Because it's not in this file. It says platform. Yeah, it just truncates it. That's interesting. I would not have expected that. I would have expected it to do the math on this. I thought that we had proper hash code for like strings and stuff. Let's look at long real quick. Yep, it XORs those. This is probably all the initial commit. Yeah. So that's inherited from Gwt. Is Jackal is same emulation. Yep, Gokdok changed it in. Oh no, it's not really changed it. Add optimal code path for common int long conversions. So what's the previous implementation? Improve to follow correct semantics. So I'm guessing it was truncating. Yep, truncating. Okay, interesting. So in that case, it's actually okay that we're gonna implicitly box integers. Sorry, implicitly convert to double and then box them. But it's technically wrong because that's not what the code is supposed to do. Let's look that up real quick and make a note about what's going to happen. Hash code is down here. That'll be a good follow-up. Okay, I think this is good enough that I'm willing to say this has basically survived a year of not being used, and the basic guts of it seem to be good. Let's see here. We already looked at point 4, we looked at point 3, point 1 and 2 got inline so much they're not recognizable anymore. For some other bug, I noticed that there was still the ability to dump intermediate output. I'd like to take a quick look at what this actually ends up with. If that equal that, return false, right? We know that's wrong. Recompiling is going to fix that. What was that other issue we had recently? Just close a bunch of these. I'm not going to need them again. It was an infinite loop in the compiler. In the inlining visitor, and my note here was this is all JS inliner junk. Never mind. I was hoping for something that would dump the class as it was being compiled, but that's not what it does. Okay. So I think the next step is going to be we go to that Java 17 AST test and start relaxing this. We don't expect a failure anymore. We expect success, so we'll go ahead and pop this out. We're going to need a bunch more tests in here for the various cases we've identified in the JEP. And check the equals. And then move on to writing some tests, or maybe make a commit and then move on to writing some tests. And put this up as a draft to say, here we're getting on the right track anyway. That's nicer. If we are actually equal, great. If we don't have the same class, fail. Cast, which it should be unnecessary because it's the same type. And then compare fields and return only if all of those are the same. Hash code is somewhat garbage. We still have the nested type there. Let's find out what happens in JShell. So if I make a class foo with a record var, and then I say new foo.var.toString. What? Square braces? I thought it was curly braces. Oh, it is square braces. Ah, and there's no space there either. Look at that. So it is eliding the parent class name. So we are technically wrong there still. So this should be square brace with no spaces. And this should be square brace. And then get short name, we want something else that will take the name, substring, last index of that. Simple name is the name as it appears in the class declaration. It does not include encoding types or packages. So that seems to be blatantly wrong. Oh, here we go. Compound name sub whatever. So if the enclosing type is null, then we return short name. If it starts with an enclosing type, or we assert that it starts with the enclosing type, and then we substring from there to be the real class name, surely we're going to go recursively here and grow the array. Take the enclosing compound name. Compound name will now be grown. The very final entry is the proper class name. So we need to access the final array and get the final element in get compound. JDeclared type does something extra here, where it calls this. I see here's the one where here's the recursive call to its parent. Get simple name should access the last one. That doesn't look right. Are we sure that works? Because this should build the component name and then access the final for JDeclared type. And in this case, type should be a JDeclared type. Let's put a breakpoint here. Something's funny. Oh, sure. It's too smart to build again with no changes. Okay, so here is we're going to call type get short name. So maybe the type name itself is wrong, or it doesn't have an enclosing type correctly. Here's the enclosing type, hello. So it should prune that off and just return .1. So if we take a look at, let's see, alt F8 type.get compound name, hello, .1. Okay. Get simple name should be .1. I did get a short name. Well, there's your problem. All right. Okay, that should be closer. All right, I think that's going to be it for me. I'm going to make, so we got our passing tests from the beginning of the stream, getting this updated and ready to go for updating error prone, which is our first step to getting Java 17 support. I have a small patch to contribute to Ahmed's initial Java 17 support fix, where we're going to provide a useful name here. That way you can see the error, the class that you've got stuff wrong instead of a null pointer exception. And then as a follow-up patch to his, I will have records roughly implemented, but not a lot of tests yet, so I need to go through and rewrite the tests. So thanks for hanging out, everybody. That'll be it for me this week. I will be online this afternoon, just doing some regular open source work here. I may switch over to something else like Clojure compiler stuff, but I'm going to keep going in Java 17 while I can, just because there's a lot to do there. So thanks for hanging out, and we'll see you next time.